Good evening, students. Today we are going to learn about cyclic quadrilateral. What is cyclic quadrilateral? What are the important properties of a cyclic quadrilateral? How the questions are framed based on the properties of a cyclic quadrilateral. In our previous lecture, we have already finished what is circle and the various terms related to circle like sector, segment, major segment, arc, chord, those things. We had also finished about the properties of chord like angle subtended by a chord on the same segment, angle subtended by a chord at the center, angle subtended by arc at the center and on the same kind of arc, whether major arc or minor arc. We have also learned about distance of a chord from the center and calculating distance of a chord from the center when the chord length and radius is known, or calculating the length of a chord when the radius of the circle and distance of the chord from the center is known. Those things we have learned in our previous chapter. Now today we are going to learn about the cyclic quadrilateral. So student, the cyclic quadrilateral, the term itself consists of two things. One is our cyclic. Cyclic simply means lies on a circle. Lies on a circle. But what have to be lies? It is the quadrilateral. Can a quadrilateral totally lies on a circle? So quadrilateral lies on a circle means all the four vertex of the quadrilateral lies on the circle. So all four vertex of a quadrilateral. Now such a quadrilateral is called as cyclic quadrilateral. A student, we have learned this is a circle. Okay, and quadrilateral is what? Any closed area with four vertex. It is called as the quadrilateral. Okay, now this quadrilateral can be drawn inside a circle. It is possible that this quadrilateral can be drawn totally inside a circle. Like this is a circle and a quadrilateral is drawn like this. It is this one. Or it is possible that take few of their vertex on the circle, but all the four vertex are not on the circle. But it is also possible that all the four vertex lies on the circle. Means we have to take all the four vertex on the circle. Okay, student, it is like this one. So this third case where all the vertex lies on the circle, then the quadrilateral ABCD is called as cyclic quadrilateral. Okay, student. In first case, we are observing that the quadrilateral is inside the circle. In second case, we are getting that only three vertices are on the circle. But in fourth case, we are getting that all the four vertices are on the circle. So such a quadrilateral where all the four vertices lies on the circle are called as cyclic quadrilateral. So only this third case, ABCD, is a cyclic quadrilateral. There is a specific property of the cyclic quadrilateral that if you consider the opposite pair of angle, like A, what is opposite to A? A just adjacent to B, then you have to go for this C. So A and C are forming the opposite pair. So angle A plus angle C, this is your 180 degree. We can also take the other opposite pair, angle B and angle D. Angle B
is equal to
plus
180.
angle D is also 180 degree. Okay. So this is the property holding for the cyclic quadrilateral. If we are considering here, in first two cases, we are observing that ABCD is not a cyclic quadrilateral. So while ABCD is not a cyclic quadrilateral, at this time we cannot surely say that angle A plus angle C, whether it is equals to 180 degree or not, that we cannot say. Or angle B plus angle D, whether it is going to be equal to 180 degree or not, that we cannot say. Okay, maybe equal to 180 degree, may be possible. Okay, like if you are drawing a rectangle inside a circle without touching their circumference, then it may be possible that it is 180 degree. Like here is a circle and I have drawn a rectangle inside it. Then ABCD
Sir, Dharanish wants to join.
is late. Student, be on time, otherwise you are losing your precious time and the important concepts. So students, for the cyclic quadrilateral, the important thing is that all the four vertex must lies on their circle. Okay, so here maybe 180 degree, but all the four vertices are not on a circle. So we have to keep in mind, for a cyclic quadrilateral, the very first point is all the four vertex of a quadrilateral must lies on the circle. Okay, so let us write down the definition. So definition of this cyclic quadrilateral is like this. Cyclic quadrilateral means what we are observing here. We are talking about a quadrilateral, means it must have four vertex, and cyclic, so all these four vertex must lies on a circle. Okay, that is the definition of this. So a quadrilateral.
Sir, somebody wants to join.
Are they people are late here? How long I shall tolerate this disturbance? If they are not interested, they can leave the class. So a quadrilateral whose all vertices, whose all the four vertices lies on a circle is called cyclic quadrilateral. The definition is so simple, called cyclic quadrilateral. This is the definition. Okay, so cyclic quadrilateral means the prime requirement is all their four vertices must lies on a circle. That is the prime condition. If any of the vertices is not laying on the circle, then it cannot be called as a cyclic quadrilateral. So wherever a circle is there, irrespective of which kind of quadrilateral is that, so all these must lies on the same circle. Okay, here we are getting that AC and BD are their diagonals. Okay, so diagonal doesn't matter whether it is passing through center or not. So diagonal is not important in this case, rather these four vertex are important for us. It may be possible that AB itself is a diameter and this C and D are at some other point. So irrespective of what is the shape and whether any of the side is passing through center or not, those things are not important. Okay, so only requirement is that all the four vertex lies on the circle. Here vertex A and C, these are what? Opposite pair of vertex. And B and D, these are the opposite pair of vertex. So there is an important property of cyclic quadrilateral. That property is like this. So write down the properties. So the first important property is that the sum of either pair of opposite angle. Here these are the vertex. The angle formed at these vertex are called the opposite pair of angles. So sum of these opposite pair of angles is always 180 degree. Write down the sum of opposite or sum of either pair of opposite vertex, we shall write sum of either pair of opposite angle is 180 degree. So this statement is very important. You have to just understand this. Opposite angle. Opposite angle of a quadrilateral means what? On the same diagonal. The angle on the same diagonal. It simply means that much. Okay? Like here, if we are considering ABCD or PQRS, consider this as A, B, C and D. Then here we are getting the angle A, this angle, and angle C, they are opposite. So right, angle A plus angle C, this is 180. Also the other pair, what is the other pair? Angle B and angle D. So angle B plus angle D is 180 degree. Okay, these are the two conditions that the quadrilateral have to be satisfied for it to be cyclic. Okay, student. So this property can be used for checking whether the quadrilateral is cyclic or not. So in figure, it may be given that all the vertex lies on the circumference of the circle. So just by watching the figure, you can say yes, it is cyclic. The other way, sometime the outer circle will not be given, the internal angle will be given, then you have to identify whether it is cyclic or not. So reverse is also true. Means what? If the sum of opposite pair of the angle is 180 degree, then it is cyclic. So write it. If the sum of each pair of opposite angle in a quadrilateral is 180 degree, then it will be a cyclic quadrilateral. Understand this? It is very important, and based on this the question is asked. Then it will be a cyclic quadrilateral. A student, what this statement tells? This tells that if sum of each pair, means there will be two pair of opposite angle, so sum of each pair of opposite angle should be how much? 180 degree. This need to be verified for the quadrilateral to be cyclic. Example, we can take like this. Consider this circle and this. Here we are observing that all the four vertex A, B, C, D are on this circle. Therefore, it will be the cyclic. It is one way of observing. But it may be given that this circle is not drawn and you are just given with this kind of quadrilateral. But here then what is given? It is given that, let us consider this angle as the 70 degree and this angle as 110 degree. Again this angle as 105 degree, this angle as 75 degree. Okay, this is given. Means the quadrilateral with all the four angles is given to you. Then you can identify whether it is cyclic or not. So let me take first one is this one, and the second one, let me take a quadrilateral where one angle is, let us take this as 100, no, let us take this as the 85 degree and this angle as 95 degree. Let us take this angle as 75 degree and this angle as 95 degree. Then we have to tell whether these figures or this quadrilateral are cyclic or not. A student, how to check? Wherever the angle is given but the outer circle is not given to you. Yeah, student, how we can check it? Very easy.
Adding opposite sides.
Very good. Opposite angle, student. Okay.
Opposite angle.
Yeah. So here, and we have to check both the pairs. Okay. So
A is quadrilateral.
yes. So for the first, you have to check for both the possible pair of opposite angle, angle A plus angle C, because they are vertically opposed. Sorry, they are on the same diagonal AC. Getting? So what is angle A plus angle C? Angle A is our 70 and 110. This value is 180 degree. Okay. And also angle B, you have to add with whom? Angle D. Getting? These are on the same diagonal. So that you have to keep in mind.
180 degree.
How much is this?
180 degree.
105 plus 75. This is also your 180 degree. So here what we are observing? Sum of each pair of opposite angle is how much, student? 180 degree. Therefore, ABCD is a cyclic quadrilateral. Okay, student? It is like this one. Now coming to the second one, whether it is cyclic or not. Let us check for the second one. Yes, student, second one is cyclic or not? Can you tell me?
No, sir.
Why?
No, 75 and
Its pair is not 180 degree.
180 degree.
Very good.
75.
So, student, you have to check for both the pair of opposite angle. So you have to check it. Here, angle P plus angle R. Are you getting how I have taken? Diagonally opposite we are always taking. Okay. They are the opposite pair. This to this one. Or if you are starting from P, you have to leave this Q. You have to go to this R.
Does not make 180 degree.
Yes. So here it is our 95 plus 85. So this value we are getting as how much? 180 degree. But just by observing this, can you say it is cyclic? No. Student, you also have to check for the other. Also, angle Q plus angle S. This is our 95 plus 75. How much is this? This is
170.
very good. So after writing 170, you have to write it is not equals to 180 degree. In one case, though we are getting 180, but in other case, we are not getting 180. So here you have to write sum of each pair of opposite angle is not 180 degree. What does it mean? Therefore, this PQRS is not a cyclic quadrilateral. So this way we can check. So this was basically the question based on checking whether the quadrilateral is cyclic or not. Okay, students. So you should be careful. You have to check the sum of opposite angle whether it is 180 or not. If the sum of opposite angle is coming as 180, then it will be a cyclic quadrilateral. And if it is not 180, then that will not be a cyclic quadrilateral. Like here, we have checked for angle A and angle C of this, the given quadrilateral, and we are observing this sum is 180. Other time we have and angle D, this pair is also 180. Therefore, this was a cyclic quadrilateral. But in the second figure, where we had taken quadrilateral PQRS, in this case, we are observing that if we are taking the angle P and angle R, then this angle P plus angle R is 180. So it's okay. But what about the other? The other one we also need to check. The other pair is angle Q and angle S. So adding the angle Q and angle S, it is not equals to 180. Means both the pair are not 180. Though it is a quadrilateral, but it is not a cyclic. Getting it, students? So this way you can verify. Okay. So applying the property second, such kind of question will be framed. So you should be careful, student. Wherever the angle is given and not the outer circle is drawn, you have to verify with the addition of the opposite angle. If sum of opposite angle is 180, then it will be a cyclic quadrilateral. If sum of opposite angle is not 180, then it will not be a cyclic quadrilateral. This you have to check for both the pair of opposite angles. Okay, so based on property 2, I have framed this question. Even based on property 1, the question is also framed. How is that question? So take one question. A student, find missing angle in following. Students, let us consider a circle in which let us consider this angle as 75 degree and this angle as say 55 degree. You have to find the angle X and angle Y. Okay, student, it is this one. This way you have to determine. The second figure, where the property of cyclic quadrilateral may be correlated to some other. Let us consider AB, and then there is another one, CD. Let us take this. Let me give both the angle. So this angle is 110 degree and this angle is 105 degree. You have to find the angle U and the other angle as V. Okay, student. So questions are very easy. Are you getting? Though it is the center O. So whether the quadrilateral is passing through center or not, that doesn't matter. What you have to observe? You are observing that the quadrilateral lies on a circle. Means it is a cyclic quadrilateral. So you have to write that. It is just my observation because all the four vertices, say A, B, C, D, lies on this circle. So you have to write here A, B, C, D is a cyclic quadrilateral. Therefore, angle A plus angle C is equals to 180 degree. This implies, what is angle A? It is given as 75 plus
75 plus X is equal to 180 degree. X is equal to 105 degree.
Very good. 180 minus 75. So X is 105 degree is our answer. Okay, student? It's so simple. Now let us come for the question number 2. So in question number 2, we are again observing the same kind of thing. Even in the first, we have to apply for C and D also. So let us
Y is also this.
also here, even in the first itself, we have to do for the Y. Angle B plus angle D is equals to 180 degree. So Y plus, it is given as 55. 180 degree. So Y can be determined by subtracting 55 from the 180. It becomes 100. How much? 25. Yes. So this much degree. So this way X and Y for the first figure we have calculated. Similarly, we can apply for the second one also. Tell me quickly.
U is equal to 75 degree and U is equal to
V is equal to 75 degree, U is equal to 70 degree.
Very good, students. So I hope all the students might be getting it. So here we can write, since, what is the relation that we can write here?
Angle D plus angle B is equal to 180 degree, which is 105 plus B is equal to 180
Very
degree.
good. So we can start with the A, means U plus 110 is equals to 180 degree. So this implies U is equals to 180 minus 110. It is our 70. Also, the other one, considering the angle B and D, V plus 105 degree is equals to 180 degree. So V 180 minus 105. Go for just subtracting it. It become your 70. Okay. So questions are very easy. These are asked in your MCQs, where just figure will be given and you will be asked for the question. A student, you please tell me one more question based on this. So find missing angle. Let us consider a circle in which center is O, and now the quadrilateral is drawn like this. And let us take one angle as 120 degree. Okay, and the other angle as, let us take this angle as 30 degree. Can we get this as X and this as Y? Yeah, student, find it. What is the value of X and Y here? Tell me quickly.
X is equal to
Degree, Y is equal to 150 degree.
Okay, Y is equals to 150 degree and X is equals to
60.
Are you correct?
Yeah.
Good. Okay, student, let me change this. Please change your value like this. The central angle is your 130 degree. Okay, now it is not 120. It is your 130 degree. Now what is the answer?
50 degrees, sir.
50 degree.
Okay, you people are saying it as the 50 degree. A student, whether it is coming as 50 degree or not, you have to verify it. How you can calculate it? How you have calculated? Tell me. Yeah, tell me quickly how you have calculated.
Sir, by 180 degree minus 130 degree.
You can get the value of X. Is it applicable here? Whether this
No, sir.
given O, A, B, C, whether it is a cyclic quadrilateral,
No, sir.
then how you people are saying that X is equals to 180 minus 130 is equals to 50? Though it may be possible to get by other way also, by the correct approach, but that approach is not correct, students. So what we have to understand, last day I had solved such kind of question where I had explained to you that wherever the center O is there and only the three vertex A, B, C are on the circle, then here this sum of opposite angle will not be 180 degree. Okay, students, so right here A, B, C, O is not a cyclic quadrilateral. Last day you people were making this mistake. Other students are getting? Yes, Sanjana, are you getting or not? Not getting, not understanding what I am doing? A student, I had explained you for a quadrilateral to be cyclic, all the four vertex have to lies on the circle. But here we are getting that the vertex O is not on the circle. It is inside the circle, though it is at the center, but it is not on the circumference. So lying on the circle means must lie on the circumference. Therefore, here we can write ABCO is not a cyclic quadrilateral. This implies you cannot write 130 plus X will surely not be equals to 180 degree, and 30 plus Y will also not be equals to 180 degree. So what is the relation that we need to keep in mind? The other relation is the angle at center and angle at the circumference by the same arc or by the same chord. So that concept we need to apply here. Now students, here we are getting that if we consider the chord AC, means if you are concentrating over the point A and C, means for this one if you are concentrating this chord, then you are getting the angle form on the minor segment is angle B. Then by the same chord AC, what is the angle form at the center that we shall look? We shall look from this direction because the angle is this way. So it is coming first. So first we shall look for this much angle rather than this smaller angle. Getting a student? Because while you are advancing toward X, you are getting that first this line, I mean this bigger angle is coming. This is our reflex angle that we need to calculate. So first calculate this angle, then you have to apply the relation for this X. Okay. So what will be this bigger angle? Yeah, tell me.
360 minus.
Yes, 360 minus 130. So students, let us call this bigger angle as U. Okay. Then you can write at center what we have. U is the denotation. So angle U is equals to 360 minus 130. How much it become?
230.
You have to just subtract it. It become 230 degree. Now, by relation, which relation, student? Angle at center is twice of angle at circumference. Or you may write central angle is twice of circumference angle. For same chord or same arc. Here AC is our chord that we are taking, or the arc AC on this side we are taking. So for this arc, the angle made at B, and this arc is subtracting the angle at center in the same order we need to take. So first we shall take the U, then this X. Therefore, here we can write U is equals to twice of X. The U that already we have calculated as 230 is equals to twice of X. So what will be the value of X, students? 230 by 2. It is your 115 degree. Are you getting? So value of X is 115 degree, student, not the 50 degree. Okay. So you should be careful, very much careful. Also, now, how to calculate this Y, student?
Angles and property of triangle.
Not the triangle of a quadrilateral. For
Quadrilateral.
any quadrilateral, if there is ABCD, any kind of quadrilateral ABCD, then sum of all the angle is always 360, whether it is cyclic or not. That is the basic property of a quadrilateral that we have learned in our earlier chapter. Also, by angle sum property of a quadrilateral, some properties of a quadrilateral. So for a quadrilateral that we are knowing, here we are taking the quadrilateral as ABCO. So therefore angle A plus angle B plus angle C plus angle O, this should be 360 degree. Means angle A plus angle B plus angle C plus angle at O is our angle COA that we need to take 360 degree. Means the A is our X that we had already calculated. So it is our, this one is our angle B. So A is given as our, it is given in the figure. Angle A is our 30 plus 115. This 15 comes here. We have taken for the angle B that we have calculated as X.
Plus 130.
Angle C we need to calculate, and angle D is our 130 is equals to 360. So what is the value of Y? It is our 385
degree
minus, at this 30 plus 115 become 145 plus 130, it becomes 270.
85.
Y is equal to 85. 85.
85, 95.
85.
Okay, student, every student is getting this. We have added this 30, 115 and 130.
Yes, sir.
So it is our 85. So this way, student, you should be careful. If you are applying this property for calculating the X, this was giving us X as 50 degree. So X is equals to 50 degree is a wrong result. And by applying this, if you are getting this Y is equals to 150 degree, it is also a wrong result. But in MCQ, this option will also be given. So students are always getting confused. So required angle is, one of the angle X is our 115 and Y is our 85. Okay, student? So you should be careful while applying these properties. So just watching or observing a quadrilateral doesn't always mean it is cyclic or the opposite angle sum is 180 degree. No, you first observe. If it is the cyclic, then you can apply. So this was all about the concept of cyclic quadrilateral and applying the angle made at the center. So student, concepts are very simple. You have to just revise all the concepts. Let me take some of the questions from your textbook. Yeah, student, tell me which question I shall solve. So let us take the question number 5.
Question number 5, sir.
5 and 6 both we will take. So let us first take the question number 5. So let us solve this question. This is our textbook, exercise 10.5, question number 5. Let us write down this solution. A student, observe the figure carefully and apply the properties of this circle and their chord and the cyclic quadrilateral if it is formed. Otherwise, here we are observing whether a cyclic quadrilateral is formed here or not. A student, can you tell me? Is this A question related to cyclic quadrilateral?
Yes, sir.
Okay, what is the quadrilateral that is formed? Can you tell me? Yes, sir, students, tell me quickly. What is the quadrilateral which is formed here? Yeah, tell me. No answer? A student, here we are getting no any quadrilateral whose all the four vertices lies on the circle is there. So it is not a cyclic quadrilateral. First thing is very much clear. Though here we are getting these are the vertex B, C, D, A. These are laying on the circle, but AD is not joined here. Therefore, it is not a cyclic quadrilateral. So which kind of question is this? Here it is given that in the figure 10.39, it is the figure given. ABCD are the 4 points on a circle, though it is on the circle ABCD. AC and BD intersect at point E, such that angle BEC is 130 degree and angle ECD, EC and D is 20 degree. Find angle BAC. You have to find the angle B, A and C. What is this angle? Consider this as X. A student, which property can be applied here? Yeah, student. Whether it is given that BC is a diameter, that is not given. So do not think that angle A will be 90 degree or angle D will be 90 degree. No, it is not given that BC is diameter. Though in figure it appears closer to diameter, but it is not the diameter. So how to calculate the X? A student, for calculating the X, you need to first find the which angle? Some of the angle you need to find it.
Sir, angle AED equal to 130 degree.
Yes, angle BEC is your 130 degree. So you may write AED as also 130 degree.
Vertically opposite
angle. That is possible. But from that, what we can get?
We should find angle.
If you are calculating this angle, then what will you get?
360 minus 130.
degree.
230 degrees, sir.
180 degree minus 130 degree is equal to 50 degree.
Yes, student, you should be careful. In this case, this X will be same as the angle D. But for calculating the angle D, we need the other angle, which is this angle. So
Sir,
if we
it
are
will be 50 degree.
this angle, then this 20 is given, then angle D can be calculated, and this angle D will be equal to angle X, because both of them are formed on the same chord BC. Okay?
Sir, angle B.
Sir, angle
AEB equal to 50 degree.
Sir, angle AEB is equal to 50 degree and angle DEC is equal to 50 degree.
Okay, good. So a student, here we are getting from this figure that if we consider angle CED, let us consider this as U, just for denotation I am writing it. So how will it be U? And let us call this angle format D as V. So in symbol you can put it and then you can quickly calculate it by the property rather than writing the bigger name of the angle. So here we are getting that U plus 130 is equals to 180. Why is this?
Sir,
It is a linear pair.
Linear pair.
This is a straight line. Are you getting a student? It is this
angle
straight
BAC
line.
equal to 110 degree.
Okay, please verify with me. So this way we are getting that U is 180 minus 130. So U value is 50 degree. A student, after calculating this U, we can go in triangle ECD.
By angle sum property.
Very good. So in this triangle, we can apply U plus V plus 20 degree is equals to 180 degree. Which one? By the angle sum property of triangle.
Answer one,
ECD.
1 sir.
Okay, good. So this U we have calculated as 50 plus V plus 20 is equals to 180 degree. A student, add this. So it is like V
70 plus
plus
V is equal
70
to
is
180
equal to
degree.
180 degree. So
V
for
is
V,
equal to
we have
110
to
degree.
transfer this 70 on the other
degree.
side. So angle V is your 110 degree. Now,
Angle X equal to 110 degree.
very good. Now,
X is
this
equal to
angle
110
X,
degree.
that you also have to write. Angle X is equals to V. Why? Angle on same arc BC. So on same
Angle on same arc.
chord BC. So both are on the same chord BC.
Angle X is it.
So
Angle
therefore,
X.
this X will be equals to V. Therefore, X is equals to also 110 degree. Okay, student. So this way you can calculate the required angle. Okay. Now please do the other question. Now let us do the question number 6. Yes, students. Please do this question number 6 and 7. Both I will give the hint. So I hope you people are getting. The questions are very simple, but you have to think a little bit. If you are not thinking properly, then you may get the wrong result. Yes, student. Tell me quickly. Solve the question number 6. And tell the answer. Yes, students, what will be the answer for question number 6? Student, here it is given that ABCD is a cyclic quadrilateral. Okay, so you can quickly put it,
All
or
four
for
would be
your
equal.
understanding, you can put it over a circle so that the figure will be drawn. Once the figure is drawn, you can quickly get it.
Angle DBC 70 degree.
Okay, let us take this as A, B, C, and D. These are ABCD is a cyclic quadrilateral whose diagonals intersect at point E. What is the diagonal? One is A to C is one of the
A to
diagonal.
C and D to B.
Very good. B to D or D to B. So diagonal intersect at point E. So write this point as E. Okay, student? If angle DBC, D, B, and C, it is given at this angle. Okay, though here it is appearing quite a small. D, B,
C is equal to 40 degree.
it is our 70 degree. Good. So please observe this. DBC is 70 degree. Angle BAC is 30 degree. Observe this. B, A, and C. It is our 30 degree. Okay, student? Find angle BCD. B, C and D. What is this entire angle? This angle is asked. Okay, student? This much angle is asked here. Get it? So what is this angle? If so, the very one thing asked here is angle BCD is equals to what? The second thing, in second case, it is the condition is given. If AB is equals to BC. This is the second case where we will look at if AB, this much length, is equals to BC, this much length, then if this condition is satisfied, then you have to calculate the angle ECD. Where is E, C and D? So mark it E, C and D. Then we need to look for this angle. So it is the second part that we will see. Let us first calculate the first part. A student, observe carefully. First we need this much angle. For denotation, let me write this by the angle X. And the next part that we will calculate, let me write this or denote it by the angle Y. Okay. So in first case, it is asked X is equals to what? From my side, I have given this entire angle as angle X. Okay. Otherwise, I have to write this angle BCD every time. So therefore, I have denoted it by X. Now, how to get this X? A student, I had told you, for getting the angle in a triangle, you observe right? Angles are
equal to 180 degree.
Angle on the same chord or the angle relation from the center and the circumference. These are the three things that you need to keep in mind. Here we are observing that if we are taking the triangle BCD, then this angle X can be calculated. 170 is there. But first we need to calculate this angle. Students, so here first I can calculate this angle BDC. How? If we are observing the BC as one of the chord, then on this BC we have two angles. One is this 30 degree, another is BDC.
Angle BCD is equal to 70 degree.
Very good. So therefore, in first we shall write angle BDC is equals to angle BAC. Why? Angle on same chord. What is that chord? It is our BC. Okay, students? BC. Yes. So this value is our how much? 30 degree. So once this value is known to us 30 degree, then obviously the X, which is this bigger angle, that can be calculated. Now write in triangle, which one? BDC. Now we are observing. May say student, now we are concentrating for the triangle BCD. That triangle is this one only, or BDC. This triangle, over this triangle now we are concentrating. So in this triangle, the angle X that we want to know, therefore we can write 70 degree plus this 30 degree
plus X is equal to 180.
X is equal to 180 degree.
X is
So
equal
in
to
this
80
triangle,
degree.
if you wish, you can write the entire name. Angle CBD plus angle CBD plus angle BDC plus angle DCB is equals to 180 degree. Why? It is our angle sum property. Good. So CBD, here we have taken this as 70, it is given to us, plus BDC that we have calculated just above, it is our 30, plus this is our X, this is 180 degree. So add it, 70 plus 30 is 100, So
Right,
x
x is
equals to
equal to 80.
180 minus 100. So value of x is our 80. Okay, student. So it is one thing that we have calculated. So this value is our 80 degree. This we have calculated. Now in second condition, for the second condition, let me redraw this figure. Okay, student. So let us redraw this figure. For the second condition, what is there? Something is given to us. What is given to us, students? So you put it.
We have to
This
find ECD.
30 we have calculated. Now this x even we have also calculated. So we can put this x also here. So this x value is our
80
how
degree.
much? 80 degree that we have calculated. Okay. Or even whether this x is required or not, that we will also see.
Minus for 30 degrees.
So, student, here it is given that if AB is equals to BC, so this condition we need to apply. Then we have to find angle ECD. So here it is given that this is the condition. So observe or represent this. AB is equals to BC. Student, when AB is equals to BC, then which two angle will be equal, or what will be the condition that we can write? Students,
Angle.
Circle.
observe this carefully. Student, let me first draw once more figure. Observe it. It is given that AB and C. AB is equals to AC. It means if we are joining the diagonal at this time, whatever this angle will be same as this angle. Can we write like this? Yes, student?
Yes, sir.
So means if this diagonal is not there, then we are observing that here triangle, or it is given that, so whatever the given, from that we have to conclude. So it is given that AB is equals to BC. This implies triangle ACB is an isosceles triangle. Okay, student. So when it is isosceles triangle, what does it mean? What we can write? It simply
Two
means,
angles are equal.
very good. So if we are denoting this a small angle by, let us denote this a small angle by U, then, or U we have used anywhere? No, we have not used it. Then what we are getting? It is given that this angle is our 30 degree. So therefore, U is
U
equals
will
to
be 30 degree.
30 degree. It simply means that. So this way, this 30 degree is determined. Now, students, from the above condition, what we have determined? What is this much angle?
Your angle ACD is equal to 40
60
degrees.
degree.
Here we have calculated this entire angle as
Sir, 60 degree.
and this we have calculated as 80 degree. Student, it was 80 degree. Okay. So what is
80
this?
degree.
Yes, what is this required angle Y? So here, since here we are observing that Y is equals to X minus U, and X we have
50
calculated
degree.
as 80 degree, minus U just we have calculated at 30 degree.
Y is equal to 50 degree.
degree is our required answer. So in this case, if this condition is given, the required angle ECD is how much, student?
50
This we have
degree.
calculated as the 50 degree. So this way you have to apply the given condition and you have to calculate it. So be careful, student. These questions are very easy, but you need to practice. Okay, that is the only way. Now let us take the question number 7. If diagonal of a cyclic quadrilateral are diameter of a circle through the vertex of a quadrilateral, prove that it is a rectangle. Can we prove? Surely we can prove. Okay, so let us take the question number 7. It is given that there is a cyclic quadrilateral whose diagonal are same as the diameter. Now we are going to solve the question number 7. This 7. Their solution we are going to do. First, draw the figure. If diagonal of a cyclic quadrilateral are diameter of a circle, means what? You have to take
The vertices will be in the
yes, you have to take the two diagonals which are passing through the center O. You may name this as A, B, C, and D. If you are joining this as AB, BC, and CD, and D. So here it is given that AC and BD are what, student? Diagonal.
Diagonals of
Good. Also,
quadrilateral.
it is
Diameter.
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 So this diameter is for this circle and diagonal is for this quadrilateral. Are you getting? Now we have to prove. So this much thing is given, and we have to prove that. Let us read the question once again. If diagonal of a cyclic quadrilateral are diameter of a circle through the vertices of a quadrilateral, then prove that it is a rectangle. Means what is to prove? ABCD is a rectangle. Student, what is the condition for rectangle? How we can prove it as rectangle? What are the properties of rectangle?
Their angles will be 90 degree. Each angles will be 90 degree.
Good. Each angle should be 90 degree and their diagonals are equal.
Yes, sir.
So here we are already getting that diagonal what are the diagonal? AC is equals to the other diagonal BD, because AC is equal to BD. That is AC is equals to BD. Why this is equal? Yes, student. Why this AC is equals to BD? Whether it is given in the question that these two are equal?
No.
Then how we are writing this as equal?
Sir, because it is a diameter.
Very good. Student, it is the diameter. So both are diameter. So while it is the diameter of a circle, surely it will be.
They are equal.
Yes. So using that property, we can write the diagonals are equal. So it is one thing. Now ABCD is a cyclic quadrilateral. What does it mean? Angle A plus angle C is equals to how much?
180 degree.
180. Sum of angle A and angle C equal to 180 degree.
Good. See here, AC is diameter. What does it mean? AC is a diameter, it means the
Equal to
angle
180.
ABC. This angle is how much? 90 degree.
90 degrees.
90
This
degree.
implies angle ABC is equals to 90 degree. Also,
Angle ADC.
good.
Angle
Angle
ADC also.
ADC is equals to 90 degree. This way we have proven this angle is 90, this angle is 90. Also,
All the four
what is
angles.
the
Angle BAC, BAD.
Angle DAB.
good? A student, for that we have to write BD is diagonal. So also
BD is diagonal.
BD is a diagonal. Diagonal rather than diagonal, we shall write diameter. Since it is diameter, therefore we are writing this as 90 degree, though it is diagonal for
DAB
the
equal to 90 degrees.
quadrilateral also. Yes. So in this case, while observing BD as diameter, we have to look the angle made by this diameter on the either side. This angle and this angle. Both
DAB
the
and
angle are 90 degree.
DCB.
Yes. So angle BAD is equals to 90 degree.
90 degrees.
And also angle BCD is equals to 90 degree.
All the four are 90 degrees.
So therefore, what we can write? Angle A or angle DAB, angle DAB is equals to angle, means all are 90 degree. ABC is equals to angle BCD is equals to angle CDA, and each angle is how much? 90 degree. Also, their diagonal are equal. Diagonal, what they are? AC and BD are
Diagonal
equal.
are equal.
Yes, AC is equals to BD. That is diagonal equal because of diameter, because both are diameter. So what we are observing, because of these two conditions, that each of the angle is 90 degree and their diagonal are equal, therefore because of these two property, ABCD is which kind of quadrilateral?
ABCD is a rectangle.
Is a rectangle. It may be possible that it could be a square also, but that is the special case of rectangle. Okay, student. So this way you have to just proceed or use the property of cyclic quadrilateral and property of the circle. Okay, student. So this way we have calculated. So this way the questions are very easy. I hope a student can do the question number 8. If non-parallel side of a trapezium are equal, prove that it is cyclic. Also very easy. Yes, student, tell me. Shall we solve the question number 9? Okay.
Yes, sir.
If circle are drawn taking two sides as the triangle as the diameter, prove that the point of intersection of circle lies on the third side. Also the same kind of thing. You have to write it properly. Okay, no? The property that we are using, that we have to write it. So in geometry, the important thing is writing.
All
Again,
the
the same
type.
prove that cyclic parallelogram is a rectangle, the same kind. Cyclic parallelogram is a rectangle. 12 is same as that we have done right now, question number 7. So doesn't any difference. You have to just copy it as it is. Because it is a parallelogram, therefore their diagonal bisects, therefore it will pass through the center. That much only you have to write. Students, let us go for the question number 9. What is given here? So you have to observe carefully what is required. Let me draw a bigger circle for this. One circle is this one. The other one is a smaller circle. It is given that and the other one is the D. Okay, these are at this intersection point. D to just intersecting it here, C. Then this one is cutting and reaching it here. Then A to C also. A to C to D. This point is our B. This point is our P. This point is our Q. The angle that we need to consider, one is this one, another one is here to here. So observe it carefully. Observe the figure very carefully. So two circles intersect at point B and C. These B and C are the point of intersection of the two circles. Through B, two line segment ABD, ABD that we are observing. This is our ABD that we have drawn. And PBQ, PBQ, this one we have this one. Okay, these are the two line segment are drawn to intersect this circle at A. D and P. We are getting A, D and P, Q respectively. These are the points that we have already plotted in the figure. See in the figure, it is also given. Then what we have to prove? We have to prove that
Angle
Angle-
ACP is equal to angle QCD.
it is this one. So observe ACP, this angle we have to prove equal to angle QCD. This angle, this we want to prove. A student, how we can proceed and what we can prove? Can anyone tell me? Which property can be used? Yes, student, any idea? You have to search for the common. What common? Common arc. What are the common arc that we can search? Yes, students, observe it carefully. If you are observing the arc AP, then what angle will be equal? If we are considering this angle as X, then obviously this angle will also be X, because this is the angle formed on the same arc. Okay, so therefore these two are X. Is it okay, students? One thing?
Angle B and angle C.
Yes. So write on arc AP. Here we can write what? Angle ACP. Angle ACP is equals to angle ABP.
BC.
Yeah, for denotation, we have just considered this as X and X, so that we can quickly understand. It is like this one. It is one thing. Now, what is the other one? Other one, a student, you can take the new arc B and DQ. You can write on arc DQ. What we can write for DQ? Students, observe. DBQ, this angle, let us call this as Y, should be equals to DCQ. This shall also be Y. Okay, so you can write this here. This implies angle DBQ is equals to angle DCQ. First two we are observing this way. But a student, observe the line AD and PQ. This AD and PQ, they are intersecting. Where? Here we are observing
P.
it intersecting like this one. So what it become? This X and Y are vertically opposite angle.
Vertically opposites.
So these X and Y will be equal. Therefore, the lower one X and Y will also be equal. It's so simple. So you have to write the other line. What is that? AD and PQ intersect at B. Also, see this figure? AD I am talking and PQ. AD and PQ intersect at which point? B.
B.
Therefore, what we can write from here? Angle
Vertically opposite
PBA.
angles.
Yes, student, angle PBA.
Angle PBA is equal to angle
DBQ. It is our third one. Now observe, where is PBA? Student, whatever this PBA we are writing, it is same as PBA is same as ACP and ABP. Are we getting? Whether you write PBA or ABP, both are same. Here we are getting ABP or PBA. So from 1 and 3rd, what we are getting that? These two are equal. So right from 1 and 3, what we are getting? This X is equals to Y. So put it. Angle ACP is equals to angle DBQ. So ACP is equals to angle DBQ. DBQ. This one. Or a student, even we can write here this angle PBA is equals to angle DBA. Applying this, we can also equate it. The other two angle means the angle ACP is equals to angle DCQ. So we can use this one as fourth. Now observe it. What we need to prove? We have to go for ACP. So ACP here we have, and other side is CQD. Where is this CQD? CQD lies with the 2, this one. Okay, we have to reach to this one. Therefore, now if we are considering this side, angle DBQ and angle DBQ. So right from 2 and 4, whatever we have circled, these two angle are equal. So therefore we can write angle DCQ is equals to angle ACP. This was to be proved. Observe, this was to be proved. Okay, so this way it is proved. Get it? So this way, what we have done, even writing is one step. Just you are observing the two arc we have taken, an angle on the two arc on the same circle you have to take. It is equal. Therefore x equal. On the other arc in orange, the y equal. But this x at B is equals to y at B because of vertically opposite. Therefore the other part, the other x and y will also be equal. Means the angle ACP is also equals to DCQ. So this was the concept that we have here. So student, questions are very easy. You have to observe it carefully. This was all about this chapter. I think if you have any doubt, then please ask. Otherwise, I shall stop it, or rather, I shall take one question from the previous exercise. Students, most of the question I have solve for this exercise. Now let us consider for this exercise 1.4, it is another important exercise.
Third.
Yes, tell me which question I shall solve for this.
Third.
Okay. Let me give the hint for these questions. Students, for the question number 1, I am giving the hint quickly. The two circle of radius 5 centimeter, 3 centimeter intersect at 2 points and the distance between their center is 4 centimeter. You can write like this or you can draw the circle like this. So draw two circle which is intersecting. One is of the 5 centimeter, other is of the 3 centimeter. So let me draw another of the smaller radius. So this is of the 5 centimeter. Let us call this as the center O, and this is at the center. Let us call this as P. Where they are intersecting, let us call this point as A and B. A student, what is here? O to A. How much is this length? It is the R1 or radius 1. It is our 5 centimeter. But what is P to A, student? P to A is our radius 2 for the smaller circle. It is our 3 centimeter.
Centimeter.
Okay? Yes. It is given like this. Intersect at point and the distance between their center is 4 centimeter. Now it is given that this much length is your 4 centimeter. So you can write OP is equals to 4 centimeter. It is one thing. And OA is equals to radius of one R1
5
5
centimeter.
centimeter. And PA, it is the radius of second
3
circle as 3 centimeter. What is required? Find the length of common chord. So we need to find AB. So AB is equals to how much? This we want to know. A student, that we have learned that if we are drawing a perpendicular from the center over the chord, it is dividing it into two equal parts. Let us consider AB is intersected by the line joining the center OP at M. Okay, M is this point. So here we can write AM have some length and MB have some length, and that will be equal. So here AM is equals to MB. Let us call this length as X. Okay, student, let us call this much length as X. A student, it is given that this OP, this entire length as how much? 4 centimeter from O to P. We may consider, let OM, this length, only O to M, this much length, as we may consider this length as some length. Let us take this as U. We are denoting it by U, or you may take this as the 4 also. No, this 4 OP is already given. This we have denoted as X. Let us denote this by some other letter. PQR we have already used. So let us use the Y here. Y is equals to Y. This thing we have assumed. We are interested to calculate AB. AB will be how much? It will be twice of X. So if we are able to calculate the X and Y, we can get it. But how to calculate this X and Y? For that, I had told you, we have to search two right angle triangles. Here we are getting that we have a right angle triangle. So let us concentrate over this. or let us redraw this triangle. The triangle is like this, student. The triangle is like this. Here we are observing that it is our A, this is our O, this is P, this is M. This much length O to A, it is our 5 centimeter. P to A, 3 centimeter. This is our 90 degree. We have considered AM as X and this much length as Y. What will be MP, student? What will be the length of MP? Can anyone
Twice.
tell me?
Twice of y.
Student, the entire OP is 4, but OM is Y. So MP will be 4 minus Y. Do not think that this M is dividing OP into 2 equal parts. No, that depends on the radius. Okay, so bigger circle, on that side OM will be larger. Getting? That we are getting from the figure also. So therefore other side is our Y minus 4. Now we have to take the two triangle. In triangle OMA, this angle OMA is 90 degree. So by Pythagoras theorem, what we can write? The hypotenuse OA square means 5a square is equals to the base OM y square plus the perpendicular MA x square. It is one thing that we can write. Yeah, student. Also, if we are considering the triangle AMP, in this triangle, again concentrate over this part, student. APMA, this part. This 3 is like our hypotenuse. Therefore, this hypotenuse 3a square will be equals to the base 4 minus y square plus the perpendicular AM, which is our x square. It is the second one. Now we have to solve first and second. That way we can get it quickly. For getting this, let us continue with the second one. 3 3s are 9. Solve this 4 minus y by the formula a minus b whole square. It becomes 16 minus 4 2s are 8y plus y square plus x square. Are you getting, a student, this match? What I have done, I have broken 4 minus y on the formula a minus b square is equals to a square minus twice of ab plus b square. Okay, a is our 4, b is our 1. Now, a student, what is this y square plus x square? This value can be substituted from this one. Yes, a student, these together can be substituted. So right, this can be written as 9 is equals to 16 minus 8y. A student, even 1 can be simplified and written like this. 5 5s are 25 is equals to y square plus x square. So this y square plus x square is substituted together here. It is our 25. Okay, student, how we have done? We have uses using 1 here. Means x square plus y square together. This x square plus y square is substituted as how much? 25. Therefore, this is replaced by 25. Okay, student? It is this one. Now, here we are getting y can be calculated very easily. So, simplify. Bring this 8y on left hand side. You have to add this 16 plus a plus 25. Yes, student. It becomes 41 minus the other 9 is on this side. Go for subtracting it. So y is equals to 32 by 8. We are getting 4 times. Student, are you not getting? So this implies y is equals to 4 centimeter. A student, what is this y? Y was the distance taken from the O to M. Therefore, what is the value of x? How this x can be calculated? X can be calculated by substituting in 1. Now, write this. Putting y is equals to 4 centimeter. This is the third that we have calculated in equation 1. How we are putting, a student? Here we are observing it is our 25 is equals to y square plus x square. So we can write it like this. 25 is equals to y square plus x square. So this y we are going to substitute. 25 is equals to y is our 4 square plus x square. 25 is equals to 16 plus x square. It means 25 minus 16 is equals to x square. 9 is equals to x square. So what will the value of x, student, from here? X square is 9. So what is the value of x?
Root of 9.
Very good. So this is our 3 centimeter. Getting? This length cannot be negative, so x cannot be negative. So minus sign is not taken here. Therefore, x is equals to 3 centimeter. X is what length? Length of this AM is x. MB is also x. So right. Therefore, chord length AB is equals to AM, or it is basically twice of AM. This AM is our x. It is x we have taken for calculation only. So this x is our, this is our twice of x. It is twice into 3. It is our 6 centimeter. Get it, student? So this way you have to use the Pythagoras theorem wherever right triangle is formed. Okay. So this question is very easy, but you have to observe it carefully. We have assumed the m. We have calculated x and y both together. Then we have substituted it. If two equal chord of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angle at this chord. Some of you are asking the question number 3. So let me explain the question number 3. Okay, student? I'm just going to give you the hint. The remaining you will do by your own. So for the question number 3, we have two equal chord of a circle. Means you just take one circle. Okay, student? You draw two equal chord. Means draw this as AB, another as CD. So what is given here? Given is our AB is equals to CD. If we consider O as the center and M and N as the perpendicular, so what this tells? We have learned that equal chord are at equal distance from the center. So this also implies MO is equals to NO. It is this one. So two equal chord of a circle intersect within the circle. It is given that one way is trying this. Other, it is given that these chords are intersecting. Means the figure may be drawn like this. See, the internal chord that we have drawn may be like this. Still the figure remains unchanged. Don't worry for the figure. This time we are going to take this C and D like this. Consider this as C, this as D. O is the center. O is this one. Then draw the perpendicular like M and draw the perpendicular on the other chord as N. So whether these chords are intersecting or not, that you have to take care. Here it is given that it is intersecting, so that's why I have drawn like this. It is given that AB is equals to CD, so how it looks equal, that we shall also take care. So here we are observing that these chords look as equal also, and it is our N. It is this one. So intersect within the circle. Prove that the line joining the point of intersection to the center make equal angle with the chord. You have to prove where they are intersecting. These two chords are intersecting. Let us call this point where they are intersecting at point E. Then you have to prove EO to the center makes equal angle with the chord. You have to prove this angle and this angle as equal. Can we prove? Surely we can prove. Why? Take the two triangle. So what you have to take? On left hand side, take the triangle MEO.
MEO.
Good. And on the other side, you have to take
ENO.
NEO. Good. These are the two triangles that you need to take. And then apply the condition for congruency. That's all. So NEO. Here what we have to prove? To prove, I shall also write here. So to prove, here is our angle MEO is equals to angle NEO. This thing we want to prove. So just we can prove these two triangles as congruent. What we are getting? Angle M is equals to angle N because both are 90 degree. So angle M on this side, angle N, each 90 degree, because it is, we have joined the midpoint of this chord, and the chord are of equal length. Therefore MO is equals to NO. This already we have written. Why?
EO is common.
A student, is it like that? Here it is given that MO is equals to NO. MO and NO are the distance of equal chord are also equal. Last day we have learned. It is distance of equal chord. It is given that AB is equals to CD are equal. So that's why we have written this. What else we can write, a student?
EO is common.
Very good. EO is equals to EO. Therefore, what we can say? Triangle MEO is congruent to triangle NEO. What is the criteria which is satisfied? Yes, student?
SSS.
Yeah,
No,
even
no, sir. No, sir.
yeah, even that SSS can also be written because NE will also be equals to EM, but I have not taken that SSS criteria. So what is this criteria? It is our RHS, student,
RHS.
because hypotenuse OE is equal in both the case. The right angle is there. Okay, each angle is 90 degree, and one of this side ON is equals to OM. So by RHS congruency. So this way we can write angle MEO is equals to angle NEO. Why? By CPCT. So this is the way of proving. So that's all. Only this much is enough. This way I have proven. So questions are, students, very simple. You have to observe it carefully and you can get it. Okay. So you should be cautious what is the asked question, and accordingly you have to do. So the important thing is considering this right angle formation by the chord and calculating their length. Last day we have learned about that, student. That property was very important, what I had explained last day. Let us quickly go through this. Are you getting? Last day I had explained you this condition. This Pythagoras theorem is satisfied in these two triangles. The same thing I had explained today also. Concentric circle. Yeah, this was the property. Wherever right angle triangle, you can apply it. Yeah, student, here we had applied. Wherever a right angle triangle is formed, we can apply the Pythagoras theorem. So the same thing we are applying here. Getting? So these were the points. Here we had written this way. Okay. So whatever the triangle we are taking, just one part, their length in term of chord entire is y. So AM we have taken as y by 2. So this way we can write. Okay. So these are the things that we had learned last day. And based on this, we have solved one of the question also. So knowing the distance of the chord from the center, what is the length of chord that we had calculated here? It was this one. Or knowing the length of the chord, the distance can also be calculated. That was also solved. Or that kind of question was also explained. So this way you can calculate it quickly. Okay, student? It is this. So this was all about this circle. Any doubt then a student may please ask. Otherwise, let us stop the class here because I have to go for class 10th. Yes, a student? Tell me quickly.
No doubt, sir.
No doubt. A student, if you have any doubt, then please post in WhatsApp. Do not forget to ask your doubt. So write down the homework. A student, whatever I had given, all this entire chapter, whatever the remaining question up to 7 I had given. So exercise 10.5, all questions, if it is left, though I had already given the some of the question earlier based on the angle concept, and 10.4 also if you have not solved it, and 10.1, 2 and 3 are very easy, only 2 or 3 questions. Okay, 1, 1, 2, 2 question, they are very easy. 10.1 we had solved all the question, that was based on the definition. 2 have also 2 question and this have also 3 question, they are also very easy, that I had explained theoretically. Okay, a student, you should be ready for your test tomorrow. If possible, I will post the
Sir, can you tell the homework? I
question.
did not